People, I am Jey and my friend Annamalai from Deep Matrix. We are quite excited because this is our first video and I hope you people too. Without further ado, let's dive into this neural network. Some of you guys are familiar with the neural network. If you are a beginner to the neural network, this is the best place to learn feedforward neural network brick by brick. Also, most of the intermediates know how to build it with some of the libraries like keras, tensorflow and PYtorch. So this video is helpful to learn it from scratch. Here are the contents of this video. The first step is to design the network structure. Wait, I will show in this image. Here x1 and x2 are the input, h1 and h2 are the neurons in the hidden layer, and the h3 is the output layer. The h3 computes between 0 and 1 because of using a sigmoid function. The formula for the sigmoid function is 1 divided by 1 plus exponent of minus y. It will also shows the result between 0 and 1. So it will helpful for a classification problem. The feedforward neural network is based on universal approximation theorem. The formula for the forward pass is y equal to mx plus c. This formula is familiar to all because this is a part of a statistics. Most relevantly, the heart of a statistic.
Hi everyone, myself Annamalai. Today we are going to see about feedforward neural network in Jupyter Notebook. Here we are going to use many libraries. The most important library is NumPy because we are going to do a mathematical interpretation with this NumPy. Matplotlib library is used to see the data sets, and sklearn have many subsets. Here we are going to use it for validating and for creating a data set. So first of all, we are going to generate a data set. Here we have a sklearn library called sklearn.datasets. From sklearn.datasets we are importing a make blobs. What the make blobs will going to do is create a data set. Here data comma labels equal to make blobs, n sample equal to 1000. Here I am going to create 1000 data points of feature 2, and it has center 2 in sense I am having a label as 0 and 1. So then we are going to see a plotting of this data set. CMap equal to CLRS. Here I am imported matplotlib.colors as CLRS. What CLRS will do is we can differentiate the data set on the basis of labels. For example, violet data set indicates it as 1 and blue indicate it as 0. So CMap, this is a code, just copy paste in a link. So plt.scatter, plt is nothing but a matplot library .pyplot. It is a third stage matplot. So scatter will do plotting of the data set. So after seeing a data set, we are going to split it. So here also we have a library from sklearn. From sklearn.model selection import train test split. What the train test split will do is it will split the data for training and test set. So wait one sec. Yeah, here you have a train size of 0.8. What it means is nothing but I am going to split 80% of data as a training data and 20% of data as my test data. So now we are going to the next part. You are building a neural network. So what I am doing is I declare a class called neuron. Define init. Init is nothing but a constructor of the class function. Here I have initiated 6 weight and 3 biases. Let's see about it. So just see this image. I have two neuron in the first layer and single neuron in the second layer. My x1 and x2 are the input. From x1 to first layer, I mean first neuron, weight 1 is initiated and weight 2 is between x1 to a2. From x2 is the second data point. Weight 3 act as a construct bridge between a1 and to x2, and x2 to a2 w4 act as a bridge. Weight 5 and weight 6 are from h1 to and h2. So from h3 I get an answer which is nothing but a output of the sigmoid function. So let's see. Now define sigmoid. This is a sigmoid function. Sigmoid function is nothing but 1 divided by 1 plus exponential of minus x. What it will do is, for example, if I have a value at thousands or lakhs, for example, if I have 1,000, when I send that value to this sigmoid function, it will scale it in between 0 to 1. So we'll set a mark of 0.5 as a middle point. So what I'm going to do is, I'm going to consider if the output of my neuron value is less than 0.5, I'll consider it as 0, and when the value is above 0.5, I'll consider it as 1. Wait, I'll show you in detail. So this is the main pass. Define forward pass. This is the main function of the neuron. So it is most like a linear regression. What I'm going to do is, I'm going to split self.x1 comma x2 equal to x. I have a value of x as 2 data points. Now self.x1 contain the first data, self.x2 as a second data point. So self.a1, just we can move to this diagram. See here, y dash equal to mx plus c. This is what exactly happened here. Now I have 2 weight, so m1 x1 plus m2 x2 plus c. Instead of that, I am using self.x1 star self.weight1 plus self.x2 star self.weight3 plus b1. See, just compare here, x1 into weight1, x2 into weight2, weight3 plus b1. So this is happening here. Now h1 is nothing but the sigmoid value of a1. So see here, self.h1 equal to self.sigmoid of a1. The value of a1 computed here will be moved to here, and the value of x will be the value of self.a1, and the value is scaled between 0 to 1. Now again same for the second layer, self.a2. See, this is the a2 layer. So x2 into w4, x1 into w2 plus b2 equal to a2. That is what I written here. And self.h2 is nothing but the sigmoid function of a2. Likewise self.a3. Now a3 is this. Here I am going to multiply h1, that is the output of the first sigmoid neuron, and h2 output of the second sigmoid neuron to their respective weight. Here w5 and w6 to a3. The output of a3 is fed to the sigmoid function, and the output is h3. So we have done with the forward pass. The main advantage of using a neural network is it learned from the data point, or it learned from the experience. So great, this part plays a major role in a neural network, because without doing this part you cannot increase the accuracy of the neural network. For example, if I have a neural network where I constructed only the forward pass and I'll predict the output, it will end up in a mess. So because of using the gradient descent algorithm, I can approximate the output of the neural network to its maximum accuracy. So we'll leave it as the gradient part as a black box for now, because it will be very tough. I'll put it in another video. So what I'm going to do is, now I'm going to fit the model. So here x is the input data, y is the label, learning rate plays a major role in the gradient descent algorithm. Epochs is nothing but number of times I am going to run my model. Display loss and initialize, there are used for particular reasons. First I am going to initialize my weights and biases. NumPy has a separate function called random. It can generate a random value. So first I am going to initialize my weights as a random values and biases to 0. I am going to initialize a set called losses. So then I am going to run my model. So see here, for I in TQDM notebook, the TQDM notebook why I am using is, it has a special function to display how much my epochs has completed. For example, see here, see this is, it will show as for example, I don't know you are familiar with Swift UI. You can see how much percentage the epochs or the model have been trained. It will show here, then see. So first I am going to initialize my dw1, dw2. These are the gradient values. I am going to initialize these values to 0. here for x comma y in zip capital X comma y, I mean for capital X comma y consists of many data point. X consists of 2 features and it consists of 1000 rows and 2 columns. Y is nothing but a consists of 1000 rows and 1 label. So I am zipping each value. So the small x consists of input data with 2 labels and y is nothing but a label. It can be either 0 or 1. So what I am going to do is I am going to call self.grade x comma y. We can move here. Oh, sorry. By moving to gradient, the next step is after the gradient class function is called, it will move to forward pass. In here forward pass will calculate the h3. h3 is nothing but a decimal value. The decimal, by using self.h3 we can use the value of h3 inside the class anywhere. So after the completion of forward pass we'll get a value of h3. Here we'll calculate the gradient part. I'll explain this in a separate video. We'll move here. After the gradient is calculated, I'll add the self.dw to a dw1 which is initialized 0 at first. I mean at the starting of the first epoch. So after adding all my loss value, I'm going to subtract it from the weight. So self.w1 minus equal to learning rate star dw1 by m. So m is nothing but a x.shape 1. This indicates that the value of m is 2. For example, the shape of x is 800, 2. So by placing a value 1 at the end of the shape, we can access the value 2. So self.weight1 minus equal to learning rate into dw1 by m. So this is a gradient part. What I am going to do is I'll set up certain learning rate value and I'll multiply the loss with that learning rate and I'll minus the value from the weight value. So here self.w1 minus equal to learning rate star dw1 slash m is nothing but I am subtracting the value of learning rate multiplied with the loss from the weight value, so that as per gradient descent the loss value of my weight move towards the global minimum. I'll explain about that in a separate video. Now just understand it here. So likewise I'll do it for weight 2, weight 3, weight 4, weight 5, weight 6 and for B1, B2, B3. So let's come to the next part. I am going to find the loss value. So ypred equal to self.predict x. I have mentioned the predict, self.predict is nothing but this function. So what it happen here is I'll send the x value. X is nothing but a array. I am unzipping a single small x value from the capital X. This small x will be moved to the forward pass and I'll add the predicted value to the ypred. Ypred I'll import it as a numpy array. So likewise ypred equal to self.predict x. So it will calculate, for example, if my x is consist of 20 value, I have a 20 labels as a predicted value. Now I compare my predicted value to the actual y value so that I can find how many loss I got. After that I add that loss to the losses set. For example, here I indicates the epoch. For example, at first I equal to 0, I'll add to the set as 0 comma my loss value. After the first epoch I'll add my loss as 1 comma the current loss, and after the second epoch I add as 2 comma the future loss. Now after adding all my loss value, I am going to see here for single epoch value I'll unzip all the x comma y from the data set and I'll predict the loss value and I'll append to it. After that, after my 1000 epoch, I'll add my losses to the list value. List is equal to losses.item. What it will do is it will create a tuple of epoch comma loss. For example, 0 comma 0.54, 1 comma 0.43, 2 comma 0.32. Likewise, it will compare. Then what I am going to do is x comma y equal to zip star lists. It will do. Now I have a lists equal to tuple values. Now I'll unzip the tuple value to x comma y. X consists of the epoch value, y consists of the loss value. Then I'll plot the value. Then that's it. This is the last part. So after running this function, I'm going to create an instance of the class sn equal to neuron.
The next step is to fit the train data. The x train indicates an input and the y train indicates output labels. The epoch is a repetition of a loop. Here I have declared it to 2000. So it will carry on around 2000 repetitions in the loop. And the learning rate is 0.001, which is completely related to gradient descendant, which I will describe it in the next session. If I go on fit the values, you can see the graph will drastically decreases from 0.35 to 0. Those minimal values can be useful to predict the test values. So it will be helpful for predicting the better accuracy. If I go on predicting the test values, the remaining 20% of a data set will be found. Sorry. You can see the decimal values in array type. I want only either 0 or 1 because this is a classification problem. I want to classify, so I want to do some computations like this. Here it will change it to either true or false, but I want only an integer value, so I want to use as type function and compute the results. Now it will change it to 0 and 1. The next step is to validating the data. Here I have used a confusion matrix. The confusion matrix is helpful in finding the true and the actual values. It is used in a classification problems. It's one of the famous computation. This is the true values. This is the true value and the actual values. 99.1 are present in the data set and the 101 zeros are present in the data set, and this 0 0 indicates that there is no negative values in this prediction. It says that it is an 100% efficient algorithm. If there is any collapse in the data in the prediction, the confusion matrix can display this results as a array. I want to remind you something. If there is any mistake in this function and this grad function, the code won't display the error, but it will show the less accuracy in the data set, in the prediction, sorry. So you can do as per the diagram shown. You can do it clearly and also use a correct formula for the loss function and also sigmoid function like y equal to mx plus c, like steps. And also the epochs I here declared and the learning rate will decide the accuracy. So this is also helpful in either increase or decrease in accuracy. So you can change this to get a better accuracy. Here I have posted the entire code in the description of this video. Meet us in the next session. Until then, enjoy machine learning. Thank you.